Welcome to the next video in our core quantitative methods course. In this video I'm going to talk about some research designs and leading up to that about some of the fundamental assumptions we tend to make in conducting quantitative research. So the plan for this is to start briefly with some philosophy of knowledge and use that to think about differences between quantitative researchers and qualitative researchers. Then look at a couple of thoughts around hypotheses, since they make up the foundation for quantitative research, and then look at research designs that actually provide the pathway from a question or an hypothesis to the answer. Regarding the whole philosophical underpinnings of quantitative and qualitative research, I don't want to go deeply into the philosophy. If you're interested, there are lots of great readings on this that can really help you to think about your own research practice. But for the purpose of this class, there are just a couple of things to point out. Our choice of research methods does depend on our answers to a couple of fundamental questions. Some of these questions are in ontology, which is the psychological study of basically what exists. So what's the nature of the world out there? Combined to epistemology, and that's just a theory of knowledge. So what do we know and how can we actually know? Historically, the idea was that quantitative and qualitative researchers have completely different answers to these questions. And sometime back a couple of decades, there were really big science culture wars going on. If you want to read about that, it's quite fascinating. Fortunately, things have softened up a bit, but still, as a general tendency, there are different answers to these questions between qualitative and quantitative researchers. So what are the quantitative answers? In terms of ontology, there is the assumption that the things that we want to study exist objectively, and there is an objective truth about relationships. So that contradicts extreme versions of constructionism and subjectivism and implies a somewhat mechanistic view of the world. Quantitative researchers also almost need to believe that these relationships are somewhat universal, because that's the whole point of the research, to find relationships that we can generalize. In terms of epistemology, we have this underlying belief that we can divide things into discrete categories and or that we can describe things by a small number of variables. Of course, the idea is not that we can describe everything about a thing in a discrete number of variables, but that we can describe a lot of it. And by doing that, we can get progressively closer to truth through the use of the scientific method. And what it is, I'll get to in a moment. Clearly, this doesn't have to be black and white. To use quantitative methods and to benefit from reading quantitative papers, we just need to believe that these things are true enough in the specific area that we want to look at for the specific question that we want to explore. And clearly, quantitative research does not claim that there are deterministic laws for all of this. It does not claim that we can safely predict whether any individual will cast a certain vote, will have a satisfying relationship, whatever that may be. We're generally out to discover probabilistic laws. So whether there are strong associations and whether the likelihood of something varies depending on the presence of some other factor. But still, how good are those assumptions? We'll discuss that in class, but I want to give you a couple of pointers to start thinking about that. So, how good are these assumptions for apples and bathwater? That should bring to mind a couple of big scientific breakthroughs. So clearly for Newton, when he was sitting under a tree, pondering why the apple just fell onto his head, it made sense to have some mechanistic worldview and to believe that the law of gravity was universally applicable. Probably hard to dispute that. For other things, like race and personality, it's already a lot less clear to what extent they are out there, to what extent they are sufficiently rigidly constructed by society for us to consider them to just be part of reality, and to what extent they are not. So maybe there are more reasons to challenge quantitative methods here. And certainly going one step further, there might be some things like studying the content of faith, studying the content of morality, where experiences are so subjective or intersubjective that quantitative methods might struggle, at least in isolation. But that's something for us to discuss. Let's consider the example of personality as something that's in the middle of that spectrum, in my view. So quantitative research presumes that there are a couple of variables that can capture a lot of personality. Not everything, but most of it. And then everyone can get a score on those variables, and those scores can then be used to predict other things. With the idea that, for example, there is an agreeableness score. Agreeableness predicts career success to some extent. This is based on what we might call a nomothetic rather than ideographic approach. So quantitative researchers are generally interested in what is general and somewhat less interested in what's very particular about single cases. And that is in part because of the influence of Karl Popper, one of the foremost philosophers of science, who argued that science has to be all about falsifiability. And as far as a scientific statement speaks about reality, it must be falsifiable. If it's not falsifiable, it does not refer to reality. And this points towards general statements, because individual statements aren't falsifiable in that sense. So what is science based on that view? Popper's view of the process was to develop a theory that informs us about some mystery, about something that we don't yet understand, to then make risky predictions derived from that theory, and then try to falsify them. And for him, the notion of falsification was crucial because it's very easy to find evidence that goes along with our theories, especially for us who made the theories based on what we already knew. So the real knowledge gain comes from seeking evidence that disconfirms our theories. However, Gustav Kuhn then is the second philosopher of science, and the last one that I want to mention, who pointed out that actually it is a lot more complicated. Science is a group endeavor. In groups, for example, there are loyalties. Not everyone is out to disprove everyone else. And not every single study has to try to disprove the foundations. So for Kuhn, there was a lot of normal science that was not about striving to falsify theories, but it was about incrementally building theories. And then there's space for true scientific revolutions. When, for example, Newtonian physics gets overturned and replaced by more relativistic views of the universe. But it's the exception rather than the rule. In any case, as quantitative researchers in the social sciences, we still like theories that make specific interesting predictions. And we then try to use data collection methods that allow us to collect data that can falsify the theory, where we can specify that some kind of possible data would allow us to reject the theory. So, in a kind of summary of this, what does it imply in terms of differences between quantitative and qualitative research? And this is really simplistic with lots of exceptions to it. But quantitative research is usually theory-based, while a lot of qualitative research rather tries to avoid prejudgments before engaging with the data. Quantitative research then needs to define and operationalize variables and then test specific hypotheses about these variables. While qualitative research has a lot more space to explore data and then to generate meaning out of data. Quantitative research is quite structured and systematic, looking for reasonably simple patterns, while qualitative research is rather interested in complexity. In that sense, it should become apparent that the discussion of what is better or worse is, at times at least, a rather futile discussion. They do just answer different things, they focus on different things. So in quantitative research, testing hypotheses is at the heart of it. So what are good hypotheses? We want them to be specific and ideally directional, because then they just tell us more about what's really going on and are easier to falsify and modify so that progress is possible. So an hypothesis that voting choices are related to income is okay. A better hypothesis is one that tries to explain in what direction. So voters with higher incomes are more likely to vote for socially conservative parties. It's the kind of hypothesis that might then easily be falsified or be only true in part and thereby give rise to progress into new knowledge. They need to be falsifiable and not tautological. Tautological just means true by definition, which is sometimes really obvious. Individuals will vote or not vote is no hypothesis that anyone would ever test. But sometimes that happens, something similar happens because of definitional issues. Strict teachers will enforce strict punishment might be an hypothesis that cannot actually be falsified. So whenever we test these things that somehow try to combine traits, categories with behaviors, we really need to be sure that they describe different things. Dictatorships, authoritarian governments don't allow independent journalism might be an hypothesis where you run into a similar issue. A country that allows independent journalism might just then be redefined as not being actually authoritarian, rather than being used to disprove the hypothesis. So we need to think about what might actually falsify an hypothesis. Thirdly, they need to be empirically testable. We need to at least be able to explain where the data might come from. So interesting hypotheses like robots will never gain consciousness might actually not be good because we can't test them. Once we have a hypothesis, the next question is, how do we get from the hypothesis to an interesting research output? And how can we evaluate other people's journey from here to there? So research design is this action plan that really describes the steps that are to be taken in the execution of the research project. They contain many different elements that are worth considering, whether we're carrying out research or critiquing research. Starting from just the purpose, the question, the hypothesis, what is this about? What variables are involved? How are those variables operationalized and measured? Which can already give rise to discussions about construct validity. What are experimental manipulations, if there are any? How are we actually sampling participants and collecting data from them? And then how are we going to analyze the data? Those are all questions researchers should answer and that they should provide clear answers to in their research outputs. So we should be able to reconstruct this from published papers as well. The design clearly needs to fit the purpose, it needs to fit the context, and it needs to think about timing. And those are three aspects I'll briefly touch on. So firstly, purpose. We might have different purposes in our research. One might just be exploratory. We know there's this thing, how frequent is it? How many people actually believe in alien abductions? A design for that would usually be a very simple cross-sectional design. We decide where we want to ask the question, we go there, we ask the question without any experimental manipulation. Another question might be, more descriptive. Are depressed people more likely to be unemployed? And those questions then often invite a consideration of directionality. Does depression today predict unemployment tomorrow, or the other way around? So we might still not do any manipulation, we might still stick to a correlational design, but we might want to do so with a longitudinal survey that collects data at different time points to try to tease out directionality. Finally, we might have explanatory studies, actually asking, for example, if vaccinations reduce child mortality. Those studies very much call for an experimental method. If explanatory studies use other methods, the design might just not be fit for purpose. One of the key questions in considering research design is also the perspective we're taking towards the thing that we're studying. So often it's a retrospective approach. We observe something, we observe that some people have heart disease and other people don't, and then we try to explain what the difference between those groups is. The problem with that is that we humans are incredibly good at explaining why things must have happened, much better than we are at actually predicting things in advance. So in prospective designs, where we actually observe a process as it unfolds, we can test our predictions much better, and it's much harder to be successful at that. So a prospective design would, for example, be one where we experimentally give aspirin to a lot of people and compare them to people who are not receiving aspirin and see whether heart disease rates differ between the two groups. A retrospective design would ask heart disease patients and a control group how much they exercised in the past. In general, it's much harder to achieve validity with retrospective designs. A related issue with regard to time is whether we just collect data once or multiple times. If we collect data once, it's a cross-sectional study where we might, for example, collect data from lots of pupils and then look at different age groups to see whether there are differences in their beliefs about gender equality. However, with that, we don't know whether we are observing maturation effects, as they are called, so effects because people have grown up between those ages, or cohort effects, because baby boomers have different values from millennials. For that, we would need longitudinal studies where we collect data multiple times from the same group of participants. So we might, again, pick a group of pupils, survey them every 2 years and see how their attitudes change. And those longitudinal studies can be a very powerful source for prospective analysis. Many countries run cohort studies with babies born in 1 year. In the UK, it's called the Millennium Cohort Studies, with babies born in the year 2000, who are now followed up over several decades to see how they develop. Those are very rich longitudinal data sets. We also can consider different contexts for data collection. Clearly, we have field experiments that are in natural settings and have very high external validity. We have lab experiments that are highly controlled. And we have more and more online studies where people do things online from home, which are cheap and convenient for researchers, but in a sense are not controlled and not ecologically valid. So they are an area where we might be able to have interesting debates. So, many different ideas in this video, and they will come to life when we start discussing real research in class. But just a couple of points to take away and remember. The first point is the importance of falsifiability for our notion of science. Popper says, being willing and being focused on falsifying your theory, finding the contradictions, finding the exceptions, is what allows for new knowledge to be created. Looking for more and more instances that confirm our suppositions is not helpful scientific practice. in order to be able to falsify theories, we need hypotheses that enable that, so they need to be specific, directional, and actually testable. If they are, we might conceivably find data that tells us that we need to think again, that we need to think harder. But with regard to research design, the two main points are the questions of timing. So do we have a retrospective approach or do we have a prospective approach? In a retrospective approach, we might suffer from the fallacy of being able to explain everything post fact. So that's something to be critical of when reading research. And do we just have cross-sectional data at one point in time, or do we have longitudinal data collected at several points in time? For each of those, how do we make sense of the resulting findings? So please bring any questions you have on this to class, and I'm looking forward to discussing some examples of research with you then.